Thank you for coming. My name is Annie Wen, and I currently work at the International Civil Aviation Organization, or commonly known as ICAO. We enable airlines such as United to fly from New York JFK to Johannesburg, transit through 8 time zones and 7 international airspaces safely. Essentially, all standards and recommended practices related to international civil aviation come from ICAO. For me personally, I caught the aviation bug at a young age. I started flying gliders at 16 and became a power airplane pilot at 17. When I began my studies at McGill University, I took my first programming class and was hooked. So I switched to software engineering, had several internships in aerospace and software, and did continue with my master's in aerospace engineering. For me, ICAO has been a wonderful place in terms of combining aviation and software. The aviation industry hasn't evolved as quickly as the tech world, so I hope this presentation will show you the potential of applying data in an aviation environment. So first, I will briefly explain who we are, how we're connected to the UN, and an ICAO-wide initiative called No Country Left Behind. Then I will explain how this translates into an approach we've developed to make decisions based on data, and then show how to apply this methodology with an example question to deep dive into the data. So the International Civil Aviation Organization, or ICAO, is a specialized UN agency for aviation. We were formed in 1944 through the Chicago Convention. The headquarters is in Montreal, where I work, and we have 7 regional offices around the world. We work with 192 member states or countries, I will use these terms interchangeably in my presentation, to reach consensus on international civil aviation standards and recommended practices, or SARPs, related to these 5 strategic objectives in safety, capacity and efficiency, security and facilitation, economic development, and environmental protection. So how does our work relate to the UN? Well, the UN has a 2030 agenda for sustainable development, and they have 17 Sustainable Development Goals, or UN SDGs. And 15 of these 17 SDGs are related to the work that we do to support the 5 strategic objectives. So now, back to ICAO, we have an ICAO-wide initiative called No Country Left Behind, which highlights our efforts to assist states in implementing ICAO SARPs. So the main goal of this work is to ensure that all states have access to the significant socio-economic benefits of safe and reliable air transport. So how do we achieve this? To facilitate data-driven decision-making to implement ICAO SARPs, we have come up with this approach. So first, we assess the current status of aviation, then prioritize the options, and finally identify the best solutions and resources available. So this is sort of the approach that we try to take in the work that we do every day to help states implement SARPs and to support the No Country Left Behind initiative. So as an example of some of the work that we do in our section, to help make decisions, this is an application where a group of states and organizations form a partnership, and they're trying to figure out which countries to help, essentially. So the idea behind this application is we have an indicator, something called safety margins. And it's an indicator that's from ICAO, which talks about the audit scores of all the countries around the world that we've audited, and their traffic. So we have their traffic data. So it's a regression model, and based on their score and their traffic, we want to see, okay, is your score high enough to support the traffic? So here on the global scale, you can see, okay, it's not so bad, but it's very hard to prioritize or make any kind of decision. But if we zoom in on a region, this is Western Africa, you're able to see very clearly the distribution on a regional level. On the southern parts, the safety margin is very poor. In the northern parts, it's doing a lot better. So from this indicator, we're also able to make prioritization into a list. So here we have the top 5 most negative safety margins. And on the right, we have added other consideration and indicators as well from the World Bank concerning corruptions, political stability, and we also looked at their GDP. So this is it's all of a process of playing with the data to see what kind of thresholds that you want to set as well. So here, perhaps this could be an option for us in this exercise. So for this presentation, I would like to have an example problem for us to go through. So there are many ways to go through the data-driven decision-making process. So this is just one example with one dimension, so to speak. The question is, which states are the least connected to the aviation network and are the best candidates for assistance? So connection here, we're only talking about physical connection. There are many ways to define accessibility and connectivity. Just to make it simple, we're looking at, okay, how far are people living away from the airport? So for this exercise, okay, 100 kilometers. How many people live within 100 kilometers of an airport? And everyone, or many states need help and need money, but who should we help first? So this is something for us to explore. So the inspiration that we got for this is actually going back to the SDG, this notion of accessibility. And this indicator talks about the proportion of rural population who lives within 2 kilometers of all-season roads. So this is an indicator that the UN already looks at. And we thought, okay, can we apply this in an aviation environment? So we thought, okay, perhaps we can. So access to airports, it connects you to the rest of the world and has potential positive economic impact. So here, I put JFK in the middle, 100-kilometer radius. You can see there are many airports. We're fairly well connected here. So to start answering this question, first we need to know where people are living. So at ICAO, we have the aviation data. We have an airport database. We know where all the airports are in the world, but we don't necessarily know anything about people. So what we did, we went to this data set hosted by Columbia University, which has a population data. This is a description. In particular, we took the 2015 data set for the world, and it is divided in 30 arc-second grid cells. Okay. So what does that mean? If we divide the world into a grid, like we have here, well, the world's a sphere, so it's 360 degrees. Each degree has 60 minutes. Each minute has 60 seconds, but we're looking at 30 arc-second grid cells, so that's multiplied by 2. When we look at the latitudes, you have plus 90 degrees, minus 90 degrees, so that's 180 degrees times 60 times 2. Let's do some math. How many points is this? 933.12 million grids. All right, that's a lot of data. So what we need to do is first to do some cleaning. The most obvious thing to do for us was to first disregard all the grids where there are no one living in it, so the oceans and many rural areas where there's no population. So that brought us down to 183 million squares. Squares are kind of hard to work with, so we translated that to a point by calculating the center of the squares. So then what we have now is 183 million points, and each with a longitude and a latitude, and each point has a value associated with it, so that's a population value. So with this, 183 million points in a shapefile was several megabytes, but we need to put it in MongoDB to translate that into JSON, turn it into many gigabytes of data. So this translation and insertion actually took a couple of days on our server. And after that, we added an index on the point because we want to query on the coordinate, the longitude and latitude. So now we have a population database. So now we know that where everyone is living. In theory, what we should be able to do is that for each airport in the world, we can find all the population within 100 kilometers of that and add it all up using MongoDB. Can anyone maybe see what could potentially go wrong here if we do this? We just add it all up, simple query. Well, what happens if there are multiple airports within 100 kilometers of each other? The same person can be counted twice, because especially in Europe, airports are fairly dense. If you take one airport, have 100 kilometers, and then another airport next to it, 100-kilometer radius, the same person will be counted twice. So then does that sum equal to the sum of the people within 100 kilometers in that country? Unfortunately, no. When we first did this, what we found was that the population of people living within 100 kilometers was more than the population of the country, which made no sense. So to solve this problem, what we did was to create a new population database, collection. So for each airport, the point is inserted into our new MongoDB collection if it is within 100 kilometers of the airport and if the point does not exist already. So now this new collection gives exactly the population, only the population living within 100 kilometers of an airport. So what we can do next with this new collection is to figure out the population on a state level. So for every country in the world, we have the geometry, kind of outlining the shape of that country. And with MongoDB, we can use GeoWithin to find all the points within that geometry and sum it all up, and which gives us the population for every country. So what we were able to do was to take 183 million documents and translated that to exactly 192 documents, one for every country, summarizing exactly the population living within 100 kilometers of an airport. And now we can do something with it with this data. So this is an example of an output. So we have Afghanistan, which has 2 international airports, 5 if you consider international and domestic. We have the population, and then in terms of number and percentages, the population living within 100 kilometers of all the airports and also the international. So this is an example of an application that I created using this data that we just went through. So for here, you can select any country in the world, and you can compare it to region. So because now our data is structured in a way that we can access it and use it very easily, we can generate text automatically to talk about the percentages of people living within 100 kilometers of international and all of the airports and compare it to different regions very easily. And here are some examples of some visuals. Here is on the whole world. So on the left, you can see where the US lie and then the group average. And comparing this in a chart, the US is more connected compared to the world. And you can also see it on a map, visualize it on a map as well. We're doing very well in North America, Europe, Africa. There could be some improvements. So I hope I was able to provide a high-level overview of what we do at ICAO, the methodology we're trying to follow, and the example of how we brought the population data into an AV context was useful. MongoDB's geospatial queries were extremely powerful in this context. We would not have been able to do this exercise in a traditional SQL database. So for us at ICAO, we're connected to the aviation world, and we use MongoDB as part of our tech infrastructure to support our No Country Left Behind initiative. And we use our data and data from other sources to create applications and visualizations which could help answer questions such as how many people are living close to an airport, which could have economic impacts.